to Lesson 2, describing the center of a distribution. So our instructional outcomes will be to construct a dot plot from a data set, and 2, to observe and describe the center of distribution and relate how the mean and the median are affected when the center is skewed. So for the most part, we're going to look at 3 data sets. We'll create dot plots for each of these 3 data sets, and then we'll answer some subsequent questions based on each of these data sets. So in data set 1, pet owners, this is the students from River City High School, which were randomly selected and asked, how many pets do you currently own? Record those results below. So if we're looking at creating a dot plot for this, all we're looking at is if I see zeros, I see a 0 here, so 1, 2, 3, and then 4. So 1, 2, 3, and then 4. So I can look at the ones. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So here we will go into this part right here and put 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. We'll go to the next part. We'll see the 2's. So 1, 2, 3, 4. So 1, 2, 3, and then 4. We can note the 3's. We'll have 1 and then 2. So 1, 2. The 4's. There's only 1 4. So 1. We can go back and look at the 5's. 1, 2. So 1 and then 2. And so on down the line, the 2 6's, the 7, the 8, the 9, the 10, and then there's 1 at 12. So this would be our dot plot for the pet owners in dot 1. Now I won't answer or discuss much more about it right now because we will have some subsequent questions coming up momentarily. So then in the class, the teacher will give the students an opportunity to take a look at this data set. The one where 20 students were selected to measure the length of an east hallway. 2 marks were made on the hallway's doors, 1 on the front of the hallway and 1 at the end of the hallway. Each student was given a meter stick. Students were asked to use their meter sticks to determine the length of the marks to the nearest tenth of a meter. The results were recorded below. And so while I'm not going to do them all, again, you will note, for example, if I looked at 8.5, we've got 1, 2, 3, 4, and then 5. So 1, 2, 3, 4, and then 5. And then, of course, all the others will be plotted in the exact same manner as we did this one. And then the third data set the students looked at was the age of cars. 25 car owners were asked the age of their cars in years. The results are recorded below, and so the students would do the same thing. They would plot the number each time each one shows up in each one. So if we just started it, the 0 shows up once, the 1 shows up once, the 2 shows up twice, the 3 shows up once, the 4 shows up once, and so on down the line. So to follow up with this, let's go back to where we looked at first in exercise 2. We see our same values that we created a dot plot, the pet owners. And so they're asking us here to do 2 things. They're asking us what is the median number and for the pets owned by the 30 students. So if we're looking for the median number that is in this particular problem. Oh, and it also says, by the way, to calculate the mean. And so we'll do the mean first, and then we'll do the median. So if we're doing the mean, all that means for the mean is to determine the sum of the values. And we're going to divide that by the number of values. So just to get started, we would say, well, 0 plus 0, and then all the 1's plus the 1 plus the 1, and we'll do this for all the numbers. A lot of time it's recommended for students in the class to say, well, all of these zeros add up to equal 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. So we know from here to here, that's worth 10. This 2 from here all the way to here, so 1, 2, 3, 4 2s, so 4 times 2 would be 8. We have a pair of 3s, so that would be 6, a single 4, a pair of 5s, which is 10, a pair of 6s, which is 12s, a 7, an 8, a 9, a 10, and a 12. So the students could add up the sums in that manner, saying 0 plus 10 plus 8 plus 6 plus 4 plus 10 plus 12 plus 7, 8, 9, 10, and 12, rather than writing every single number out individually. And then the number of values, we know that there were 30 students in the problem, so we would divide by 30. So when we do that, the mean would end up equaling 3.2. So if you haven't done so, you may want to pause the video, take a moment, and confirm for yourself that you get an average or a mean of 3.2. So when we're talking about the median, I'll erase this so we can talk about that data. So the median is the number that's in the middle. And so one of the ways that students can take that opportunity is start on each end and start to cross out. So we'll cross this one out and this one, and you go from one each end. And this is how students start to figure it out. But when they get better, they could always start, say, go 1, 2, 3, 4, 5, and come back over 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, just to get them through it quicker. 1, 2, 3, 4, 5. So now we're close, 1 and 1. And so here we have two numbers in the middle, because we have an even set of data. So if we are trying to find that median, it's going to be 2, but let me explain why it's 2. In this case, we would have taken those two numbers, 2 plus 2, added it up and divided by the number of values, which is 2. So you would get 4 divided by 2 is equal to 2. It's important just to note that idea or method, because sometimes the two numbers in the middle are not always the same. And so they're not the same, you would need to find the average of those two numbers to calculate that. So that is what we have found so far. The mean, which is right here, and the median, which is 2. In exercise 3, following the same thing, what do you think is a typical number of pets for students from River Oak High School? Explain how you made your estimate. And so when we look at it, here's the dot plot that we created at the beginning of this presentation. And so the median would probably, because remember we just said the mean was 3.2 and the median was 2. Now we want to know that our data tends to be skewed. So we have a skewed data set with a tail to the left. So we're asking our students, what do you think is a typical number of pets from this situation? Explain how you made your estimate. So most students would probably say that somewhere in this region here would be the typical number of pets owned, between 0 and 2. And so when we ask the students which one of these numbers do you think best represents the typical number, the students would say the median would be the better represented number as 2 as opposed to 3.2, just because it's a little bit closer. And so what students will tend to learn is that the median tends to be a better fit for skewed data, and the mean will be better when the data is not so skewed. In exercises 4 through 6, this brings up the same measurements we looked at earlier about the students measuring the hallway. So in number 4 it says, why do you think that different students got different results when they measure the same distance of the east hallway? And so students would say, well, measurements can occur as a result of the placement of the ruler. So someone might have put their ruler slightly in the wrong place when they measured. The alignment of the ruler after each length was made, and a different interpretation made by the person making the measurement. So in other words, human error could be a reason why some of the different measurements were different, because we had 8.2 at the low point and 8.9 at the high point. In question 5, what is the mean length of the east hallway of the data? And then what is the median? So again, we talked about how to solve the mean. That would be we would add up all of these numbers. We're going to divide that by the number of students that had measured the hallway. And so in the end, we determine that the mean is equal to 8.57, and the median, when we go through and mark each one on each side and find the number in the middle, we end up with an average of 8.55. So in this one, number 6, a construction company will be installing a handrail along a wall from the beginning point to the ending point of the east hallway. The company asks you how long the handrail should be. What would you tell the company, and to explain your answer? So here we tend to see what's interesting is the data, it doesn't have a very big skew to it. You see it goes down here, kind of comes up, and comes back down. We want to tend to kind of call that symmetrical. So when we design this, the students will kind of say, well, since the distribution is nearly symmetrical, not perfect, most of the data is best represented by the mean, which should be used as our center. So if we're trying to tell the company how high the handrail should be, and the mean is the more appropriate piece, we might round this, though, to approximately 8.6. We might say 8.6 to the construction company would be a nice appropriate size to put that handrail. In that third dot plot, we looked at a situation where we had 25 car owners come in and tell us the age that they were. So in question 7 it says describe the distribution of the age of the cars. So one thing that we'll note is that our data is not symmetrical. It's skewed in this manner with a tail over here to the left. What is the mean age for the 25 cars, and what is the median age for the cars, for the age, and then why are the median and median different? So the mean age for the cars, after you solve it, and again that's adding all these up and dividing by 25, you're going to end up with a mean age of 5.84, and then the median is going to be 7. They are different. Obviously, they're not very close. The mean is smaller because of the small values in the tall part of the data distribution. So in other words, it's not symmetrical. We have a whole bunch more data over here, but we had data over here that kind of brought that mean or that average down to this region. But the median age, where a lot of the data exists, is over here at 7. So 9 says, what number would you use to estimate the typical age of a car for the 25 car owners? And so we would say the median would probably be the better estimate here, being that it's a skewed data, and so we would go with median, and we would say approximately 7 would be the typical age for a car of these 25 car owners. And that's again based on choosing median because the data set itself is skewed. So in closure, the class talked about how was the choice made between mean and median. It's where we typically said that if it was the mean, we want to see data that is symmetrical, versus if we're using the median, we tend to use data that is skewed to describe the data distribution. And so then we also had the opportunity to sketch a dot plot in which the median is greater than the mean. Could you think of a context that might result in the data in which this would happen? And so that takes us to the thing where if we had a dot plot and most of my data would be over here, and then it began to tail off to the left, my median would fall somewhere over here, while my mean would fall somewhere over in this region.